Hello students, I hope you all are doing well. Now that your IMUCET papers are over, I trust your exams went well. So today we'll be discussing our physics paper. So this is a guest paper, so there might be some discrepancies with the paper, but this today we will just discuss this. So when we talk about physics paper, so the paper was moderate. The questions were not very difficult. There were multiple questions which I would say would have been solved in one go without even lifting the pen, right? Yeah, they were mostly formula based, topic specific that might be possible. We have discussed this multiple times in our batch that we should that please ensure that may make a note of each of the questions, right? Each chapter that you go through, please make a note of all the formulas that you have discussed to the chapter, right? Because mostly you don't get theoretical question, and as you can also see from this year's paper, the questions were not theoretical or not long or lengthy question, right? Mostly the questions were formula based to the point, right? So let's get started and we'll see. Now, for the first question, a block of mass 2 kgs is placed on the floor. The coefficient of static friction, Fs, is given as 0.4. All right. Now, if a force of 2 Newton is applied, 2.8 actually, on the block, onto the floor, the friction between the block and the floor is, now, let's see. How much friction, how much is the force of friction? This is the force that the person is applying, applied force. How much is the force of friction? So how do we calculate it? The force of friction is what? Reaction force with this and the product of coefficient of friction. Now what is reaction force? Reaction force is mass of the object and gravity, correct? So 2, and let's take G for here as 10. So the reaction force will be 20 newtons. So friction force is 20 into 0.4. So that gives us how much? 8 newtons. Now the applied force, since the force applied is less than the force of friction, in that case what happens? Till we reach the limiting value, the friction force and the applied force, the friction force tries to balance out the applied force, right? So the force of friction will be equal to force applied, correct? So your answer is option A. Now, moving on. Two bodies of mass 1 and 2 kgs are lying in xy plane. It is given here. The body 1 has -1, 2 coordinates, and the body of mass 2 kg has the coordinates 2, 4. It is asking for center of mass. Now, to calculate center of mass, what will we check? The basic formula x1 m1 plus x2 m2 divided by m1 plus m2. For this question, I think you did not need pen, right? It was just, it would have been done in your mind only, correct? So here 1k minus 1 into 1, that gives us 1, and then we have 2 into 2. So that gives us 3 by 3, comma, what else? Minus 1 kg into 2, that gives us another 2, and 4 kg into 2, 6, correct? 8, sorry, 8. And total mass 3. So that gives us the option D. Now, moving on. If two balls are projected at 45 degrees and 60 degrees, and the ratio, then it is asking for the ratio of the initial velocity. Now for this, I think the question here is incomplete. It should have given that the initial, not initial, it should give us that maximum height, not this one, maximum height for both is same. Or it can also give that max height, max, or the time, not max time, the time of flight. Time of flight is same, right? Now, for this question, I think it was a maximum height was same. So what is the formula of maximum height? U square sine square theta upon 2g. So now if we equate it, u1 square sine square 45 degrees upon 2g would be equals to u2 square sine square 60 degrees divided by 2g. These two values will get cancelled. Now, what are we left with? U1 square divided by U2 square. That is equals to sine square 60 by sine square 45. Correct? That we give it as 3 by 4 divided by 1 by 2. So we get what? 3 by 2. So U1 by U2 will be equals to under root 3 by under root 2. So we get as option A. Now, moving on. Let's see. So particle of mass 10 kg, 0.10 kg, 0.1 kg is given. Executes an SHM with an amplitude of 0.05 meters. Okay. And frequency is given as 20 vibes per second. Now, it is asking for the energy of oscillation. What is the energy of oscillation? Again, a formula based question, 1 by 2 m omega square a square. Correct? Now, we have the value of a square. We have to find out omega square. We also have the value of m. Now, how will we calculate omega square? So, we know that omega is equals to 2 pi f. Correct? We have f given as 20. So, omega will be equals to how much? 2 pi 20. So, that is how much? 40 pi. Now, put these values 1 by 2. Just 1 by 2, mass is 0.1, omega 40 into 40 into pi square multiplied by a square, that is 0.05 into 0.05. Correct? Evaluate this. How much value will we get? We can take this as 9, 10, right? Pi square is almost equal to g. So we can take this as 10. So if you evaluate this, you will get the value equals to 2 joules. Alright? Now, moving on. So it is given the diameter of a hollow metallic sphere. Diameter is given as 60 centimeters. Okay. And the sphere carries a charge of 500 microcoulombs. Now what is it asking? It is asking what is the potential at a distance of 100 centimeters. What is the formula for potential of a sphere? Now, this potential that it is asking, it is beyond diameter, right? So R that is asking is greater than the radius of the sphere. So what is the formula? KQ upon R, correct? K is 9 into 10 to the power 9. Q we already have 510 to the power minus 6 divided by radius, that is we'll convert it into meter SI unit. So we'll take it as 1. Now, let's not, even if we don't do the calculation, 9 5 is 45. So we get it here. The answer is A. Correct? You can use these tricks, right? Now, moving on. So this also question did not need lifting a pen, right? Now, it is asking two ions having mass 1 is to 1, mass ratio 1 is to 1 and charges in ratio 1 is to 2 are projected perpendicular to the field of cyclotron. This also is a formula based question. It is asking for the radii of the path. The path radii is given, right? mv by into q divided by v, right? Now, we already have the ratio of mass. We have the mass ratio m1 by m2 is equals to 1 upon 1. We already have the charge ratio q1 by q2 equals 1 upon 2. Correct? And we also have the ratio of speed v1 upon v2, 2 by 3. Now, if we put this value, r1 upon r2 will be equals to how much? m1 upon m2 multiplied by v1 upon v2 multiplied by q1 upon q2. Right? This p value will get cancelled because they are both kept in the same medium. So now if we just take the product of this, how much will we get? 1, 1 by 2, 2 by 3. Correct? Now moving on, we have two ions having mass in ratio 1 is to 1 and charge in ratio 1 is to 2. So m1 upon m2, we have 1 is to 1. And q1 upon q2, we have 1 is to 2. What else? It is given that this is projected perpendicular to the field of cyclotron with the speed v1 upon v2 as 2 is to 3. Now, are we aware of this formula mv upon r is equals to qb? Correct? mv upon r equals to qb. So now can we take this value of R as equals to mv upon qb? Now been given all these values. So if we take the ratio R1 by R2, that is the radii of the circular path, that will be equals to how much? M1 upon M2 into V1 upon V2 and reciprocal of Q, right? Because Q is in the denominator, Q is inversely proportional. So Q2 upon Q1. If we take these product, what will we get? 1 into 2 by 3 into 2 by 1. So that's we get 4 is to 3. This is also, this was the base formula. But this was also a formula based question, right? We did not need a lot of time for this. Now, moving on. A particle of mass 2 kgs, mass of the particle is given 2, is moving along a circular path of radius 1 meter. So radius is given as 1 meter. If the angular speed is 2 pi radian, then the centripetal force on it is, so it is given as radius as 1 meter and angular force is given as, angular speed, sorry, omega is given as 2 pi, right? So now it is asking for centripetal force or Fc. So what is Fc equals to? First of all, Fc is F. Force is equals to mass into acceleration. So you'll have to find centripetal acceleration first. And now, what is the formula of centripetal acceleration? A is equals to R omega square. Correct? Now, what is the value of R? R is given already 1 meters. And what is the value of omega square? 4 pi square. Correct? Now, we can just put this value of A is equals to 4 pi square in Fc. So, Fc will be equals to how much? 2 into 4 pi square. That gives us 8 pi square. Correct? Again, option D. Moving on. Now, next. Some electric bulbs are connected in a series. So, we have a series connection of bulbs, right? Across a 220 volt supply. Now, what is it asking? If one bulb is fused and the remaining are connected in series across the same supply. So, if we remove this one bulb, then the illumination of the room will, see, what is happening here is if one of the bulbs is getting removed, now this extra power that was consumed by this bulb will be consumed by the other bulb. So the illumination of the room will increase. Okay. All right. Moving on. Now the torque of force F is given here on a point R. About origin will be. So it is asking what is the value of torque. What is the formula of torque? F cross R. Okay. So we just take the matrix product of this. So F is minus 3, 1, 5 and R is 7, 3 and 1. We just take the product. So for I it will be 1 minus 15. For J it will be minus 3 minus 35 and for K it will be minus 9 minus 7. So we'll get how much? Minus 14 I cap plus 38 J cap minus 16 K cap. So we get answer as B. Correct? Moving on. Now, a body is falling vertically downwards. So we have an object, let's say it is falling vertically downwards. Under gravity, breaks into two parts. So this object is breaking down into two distinct parts, okay, of unequal masses. Now, taken together. So, how two distant parts of unequal masses. The center of mass of the two parts taken together shifts horizontally towards. Now, see, the body is falling vertically downwards. So, there is a gravity, a force acting on it, but in a vertical direction. There is no horizontal force here, right? So, since there is no horizontal force that is occurring on the body, there will be no horizontal shift on the center of mass, right? There will be no shift. Moving on. A ball of mass m is moving towards a player with velocity v. The player stopped it, then the impulse implied by the player is, now what is impulse? Change in momentum, right? Now when the ball was coming towards the player, what was the initial momentum of the ball? Mass into velocity, correct? Now once the player stopped it, so this is your p initial, and once the player stopped it, what is the final momentum of the ball? Since velocity became 0, momentum will become 0, correct? Now what will be the impulse? The impulse I will be P final minus P initial. That is 0 minus mv. So we get minus mv. Correct? Option B. Moving on. Two wires of same material, length, same material, same length and diameter in the ratio of 2 is to 1. They have a ratio in diameter are stretched by the same force. So it is asking U per unit volume of the ratio. What is U? Elastic potential, right? Elastic potential. Now, it is asking that both the wires, they are made of same material, they are same length, and there is the ratio in the diameters. Okay. Now, and the force applied on the both of them is also same. So now, what is the value of U? How do we calculate it? U is equals to 1 by 2 stress square upon Y. What is Y? Young's modulus, correct? Now, we'll have to calculate stress for both the objects. What is the value of stress? Force per unit area. Now, they have different diameters, correct? So, area might differ. And if the diameter ratio is 1 is to 2, the radius ratio will also be 1 is to 2. So, now let's take U1 and U2. Okay. So, A1 will be equals to pi r square and A2 will be equals to 4 pi r square. Correct? Because R1 is R and R2 is 2R. Correct? Now that we have that, so S1 will be equals to F upon pi r square. Not here. Okay. So F1 upon pi r square and S2 will be equals to F upon pi 4 pi r square. It is also given that the force which the both are that is applied on the both the objects is same. Correct? Now, so what do we get the ratio of stress? S1 upon S2 will be equals to how much? If we take the ratio of these two, we'll get the value 4. And as we can see that the value of this, the ratio of U or elastic potential, so U1 upon U2 is equals to S1 square upon S2 square. So that is 4 ka square. It will be 16, correct? So our answer will be C. Now, moving on. If a body has weight of 72 newtons, when it is when it is taken at the height h is equals to r, radius of earth, what would be its weight? So its initial weight here is 72 newtons, right? Now, how do we calculate gravity when it goes when the radius increases? We have this formula, right? We'll take gravity at height h or height we'll take it at height h will be equals to how much? Gm upon r plus h the whole square, correct? Now, what is the value of h here? Here h is equals to r. So Gm upon 4r square will be the value. Now this is the same value G, correct? So now GH or gravity at height h will be G upon 4, correct? And when we talk about weight, what is weight? Mass of the person into gravity, correct? So now weight at height h will be equals to mass of the person into G of h. So so now we can just take WH is equals to W upon 4, right? Because G of H is G by 4. That gives us W is equals to 18 newtons, correct? Now, moving on. The ratio of amplitude of magnetic field to the amplitude of electric field of electromagnetic wave propagation. So this is also a concept-based question. Epsilon naught upon B naught. This is a constant, right? We have you might have discussed or saw this equation in EM waves, correct? So it is equal to 1 upon c, or the reciprocal of speed of light in vacuum. Next, electric dipole of an electron and a proton. Now, what is electron? What is the charge of electron? 1.6 into 10 to the power minus 19 coulomb, correct? Now it is saying that one is electron, one is proton. So the proton will have same positive charge as the electron has negative charge. Now what is the formula for dipole? Q upon Q multiplied by distance, correct? So we have the value of Q, we have the given distance given as 4.3. So 1.6 into 10 to the power minus 19 into 4.3 into 10 to the power minus 9. Even if we don't perform the whole calculation, 1.5, 4.3 will get the value nearby 6.8. Okay, moving on. The RE is the Reynolds number, correct? Which of the following is incorrect? Now here if we see if the RE ranges between 1000 to 200, the water flow is steady, correct? If the RE is less than 1000, the water flow is laminar. This also statement is true. And if RE is greater than 2000, then the water is turbulent. This statement is also true. So none of these statements are incorrect. So in that situation, either the option should be all correct, not incorrect, or since none of the options is correct, we can also mark it as all are incorrect because none of the statements are false. Okay. So option can be D. Okay. Moving on. A charge Q is enclosed by a Gaussian surface. So we have a Gaussian surface here and a charge Q is enclosed inside it. Now, if the radius is double when then the outward electric flux will. So when we talk about a Gaussian surface, the flux is equals to what? Q enclosed upon epsilon naught. Now, even if the radius is increased, the charge enclosed inside the surface remains the same. So because of that, there will be no change in the flux. Okay, the Gaussian the flux will the electric flux will remain the same. Moving on. In an elastic collision, what is an elastic collision? Where the coefficient of elasticity is 1, right? Coefficient of restitution is 1, sorry. So in that case, what happens? The kinetic energy is also conserved and the momentum is also conserved. So the option will be D, right? So these are the ideal case collisions, correct? Now moving on. A circular coil of 20 turns. So it is given number of turns n equals 20. 8 A circular coil of 20 turns, 8 microjoules equals 10 centimeter. Okay, it has, I think there's something wrong written here, but okay. And you have been given the value of mu, and mu is equals to 10 centimeters. Is placed in a uniform magnetic field of 0.1 Tesla to plane of the coil. So the current in the coil is I is also given to us 5 amperes, right? Now what do we have to calculate? We have to calculate the torque here. Now the torque will be how much? It will be mb m cross b, correct? Now what is m here? M is the magnetic moment. How do we calculate magnetic moment of this coil? We calculate magnetic moment by n is equals to nia, correct? N is the number of turns, 20. I is the current that is flowing. A is the area, cross-sectional area of the coil. So we already have been given the radius, correct? So the radius is 0.01 meters. So from that we can calculate area as pi r square or pi mu square. So that will give us 0.0314 meter squares, correct? Just put this value here 0.0314 and we'll get the value of m. Okay, and the value of m will be how much? 3.14 ampere meter square. Now we can just put this value. So now it is saying that it is placed in the uniform magnetic field to the plane of the coil. So now if we are saying that it is placed at to the plane of the coil, that means it is making an angle of 90 degree, correct? So now if we take tau as mb sine theta, so now the value of theta is 90 degrees. So we have the value of m, we have the value of b, and sine 90 is 1. So if we just multiply these, we'll get the value as 0.314 Newton meters. That is option A, correct? Moving on. Now, a current through a wire depends on on time. Okay, so it is given that the this I flow, it depends on the time, 3t square plus 2t plus 5. Now, we are also aware that dq by dt is equals to I. So it is asking what is the charge flowing through the cross-sectional wire in the time interval 0 to not 25 seconds, 2 seconds. Okay. So we can calculate d. So we'll be getting dq as I dt. If we integrate both ends, we'll get q is equals to I dt integration from 0 to 2. Now, if we just integrate this equation, it will be 3t square. If we just integrate this equation here, we'll get how much? Tq plus 2t square upon 2 plus 5t. That gives us tq plus t square plus 5t. If we just put the range 0 to 2 here, we'll get 8 plus 4 plus 10. That gives us 22 coulombs. The answer is E. Alright, moving on. Now, it is given that the potential difference between two plates of the capacitor, we have two capacitor plates. So, one is 10 volts and one is minus 10 volts. Okay. The charge on one of the plates is 40 coulomb. So, charge on one of the plates is, we have been given the value of Q as 40 coulombs. Now, how much is the voltage difference? See, from here to here, voltage difference will be plate A minus plate B. Correct? So, that is 10 minus 10. That gives us 20 volts. Correct? That is the voltage difference between the two poles. Now, we know that Q is equals to CV. So, if we have to calculate this value of C, that is equals to Q upon V. That is 40 upon 20. That gives us option 2 Farad, or it is equals to 2. Correct? Moving on. Now, a body is executing SHM with an amplitude of 0.1 meters. Okay. So we have the value of A as 0.1 meters. Its velocity while passing through the mean position. So see, the object is here. Let's assume that this object is a pendulum. Okay. It is going from here and then coming to the center and then going again back. Okay. So whatever. So it is saying that when it is passing through the center, it's passing through the mean position. Its velocity is here at the mean position is 3 meters per second. Okay. Then what is the frequency here? Now, first of all, if you know the formula, V is equals to A under root omega square minus x square. This is one of the most important formula of SHM. Now, if it is saying that when it is passing from the center here, the value of x will be 0. So, V equals to A under root omega square. That is equals to A omega. Now, we already have the value of V as 3 and we have the value of A as 0.1. So, if we put that, we'll get the value of omega as 30 radian per second. Right? Now, what else it is asking? Frequency. You know that omega is equals to 2 pi f. So, what will be the value of f? 30 upon 2 pi. That is 15 upon pi. So, the answer is D. Moving on. A force of 2i cap plus 3j cap plus 4k cap is acting on a body for 4 seconds. It's not 45 seconds. 4 seconds. Produces a displacement of 3i cap plus 4j cap plus 5k cap. Okay. What is the power used? What is power? Work done per unit time. Now what is work done? Force into displacement upon time. So we'll just take this product. 2 into 3, 6 plus 3, 4, 12 plus 5, 4, 20. Right? We'll take the dot product. In dot product, we cannot multiply different variables, right? We multiply the I cap to I cap, j cap to j cap, and k cap to k cap. Now we take this and divide it by whatever time period it was. How much is it? 4 seconds. So with that, we'll get 9.5. That is your work done, right? Most of the questions are very basic formula based, right? Now, a particle moving with a constant angular velocity along a circumference of a circle, which statement is true? I think this question is incomplete here. So what it is trying to say is that the particle is moving across a circular motion, right? Now, if we take the projection, what is projection? If we display a light, let's take it in 2D. Now, if we put a light here, then and here we put a, let's say, a wall or something. Okay. Now in 2D, if we see the particle moving, now let's see. Let's start from here. If the ball is here and you project a light from here, the ball will be visible. The shadow will be become here. Now let's let it go here. Let's start from this point actually. Okay. So the ball is here. So and the light is projecting. So the image will come here. When the ball went here, the image comes here. When the ball comes here, the image comes here. So like this, and once it reaches this point, and after it starts coming back, it will again start from here, right? So it is executing a SHM, right? So that is what this question is asking. A particle is moving with a constant angular velocity along the circumference of a circle. So the projection along diameter, that's what the question should be, is executing SHM or not. Okay, so it is executing SHM. Now moving on. A solid sphere is rotating freely about its symmetric axis in free space. The radius of the sphere is increased, keeping its mass same. Now, which of the following quantities would remain constant? So, if we do not provide any external impact, which quantity will remain untouched? The angular momentum. That remains conserved, correct? And since we are not using or providing any external change or external influence to it, there would be no change in the angular momentum, right? So option B. Now, moving on. Two pure inductors, each of self-inductance L, are connected in parallel. So for inductors, what is the parallel connection? L1 plus 1 by L2 is equals to 1 by L equivalent, correct? So L equivalent will be how much? L upon 2. You do not even need to lift a pen for this question, right? Now, if a correct engine functions at the source temperature of, if a Carnot engine, not correct engine, Carnot engine, functions at the source temperature 127 degrees Celsius and the sink temperature 87 degrees Celsius, right? Now, what is the efficiencies? How do we calculate it? T1 minus T2 upon T1. That is your Carnot cycles, Carnot engine's efficiency. Now, we take this in Kelvin scale, correct? So, just put these values in Kelvin scale plus 273. That will give us what? 400. And this will give us how much? 360. So, now we have 400 minus 360 divided by 400. That gives us 40 upon 400. So the answer is A, right? Now moving on. The ratio of terminal velocity of two drops of radius r and r by 2. Now if you guys remember the formula, I mean it was a long formula so I'm not expecting a lot. But the formula wise it was the value of terminal velocity v was equals to rho 4 upon 3 pi r cube into g upon some 6 pi mu r, right? This was the formula. But basically at the end of the formula it was given that terminal velocity is proportional to radius square. Correct? So now it is given that R1 and R2 are in the ratio 2 is to 1. Correct? So now it is asking what is the ratio of the terminal velocity. So R1 square upon R2 square. So that gives us 4 is to 1. That is option A. Right? Moving on. An intrinsic semiconductor is an electrically neutral. Okay, intrinsic semiconductors are electrically neutral. Extrinsic semiconductors have large numbers of current carriers. So if the extrinsic semiconductor is having a large number of current carriers, would it be positively charged, neutral, negatively charged? Now, until this conductor is forward biased, then only there is a charge amplification happening here. Until then, the positive charge, it remains electrically neutral only. Okay. Now, moving on. In which of the following transition the wavelength will be minimum? Now what is the formula for this wavelength calculation? 1 by lambda is equals to rz square 1 by n1 square minus 1 by n2 square. Correct? If we just put these value, whichever will have the maximum value here, whichever will be having 1 by lambda max will have min lambda. Correct? Now, if you just put the values here, 1 by 2 cos square, sorry, let's take for case A, it will be rz square 1 minus 1 by 4. That is 3 by 4 rz square. For case B, it will be rz square 1 by 4 minus 1 by 9. So that gives us what? 7, 5 by 36 rz square. For C case, we have rz square 1 by 9 minus 1 by 16. That gives us 7 rz square upon 144. And lastly, for the same thing, we'll get rz square upon 9 divided by 400. So this will be the minimum value, right? Moving on. If the earth suddenly shrinks to half of its present radius, if r becomes r by 2, right? Then the acceleration due to gravity will be, now it is not given if the mass will also reduce or not. But for most of the questions, it is given that the mass remains same. So in that situation, r becomes r by 2. So g dash will become how much? Gm upon r, whatever r dash, let's say. Gm upon r dash will be the new gravitational force. What is r dash? R by 2. That is Gm upon r. And this 2 can go up. So g dash will be equals to 2g. Correct? Sorry, r square. Right? So 4 should be 4g. Right? So option A. Moving on. In a certain region of space with volume of 0.2 meters, an electric potential is found to be 5 volts throughout. So we have a certain region here. In this region, the electric potential is found as 5 volts throughout. Okay. So it is asking what is the magnitude of electric field in this region. Now, since there is no difference in electric field, so there is dV is equals to 0. So dV by dx, that is your electric field, this will become equal to 0. So since there is no difference in electric field is throughout constant. So the answer is 0. Moving on. Electric dipole moment of electron and proton 4.3 meter apart. Same question that we discussed earlier, right? It is option A. Okay. Now, next. A string of length of the string is given as 1 meters, has a mass per unit length of 0.1 gram per centimeter. What will be the fundamental frequency? Now, for this, what is the formula here to calculate it? The fundamental frequency is 1 upon 2n under root T upon mu, correct? Now, we have the length as 1 meter, so that is fine. T is the tension. What is the tension in the string given? 400. So, 400 divided by, what is the value of mass? So, it is given as length as 0.1 grams per centimeter. So, we'll convert it into meter. That will be equal to how much? 0.01 kg per meter. So, just put this value here, 0.01, because it is asking for 1 meter only, correct? So now if we calculate this, you'll get the answer of 100 hertz. So the option is D. Now, it is given that we have a circuit of I, where I current is passing as 2 amperes through a cell of EMF 5 volts and having a resistance of, it should be given in ohm, 1.15 ohm. Okay, so we have a cell here. It has some internal resistance, and because of this, the current flow that is happening is 2 amperes. Okay. So the current flow that is happening is 2 amperes. It is asking what is the potential difference across the both ends of the terminal. Okay. How do we calculate it? We'll take V is equals to what? Whatever the actual voltage we are stating, 1.5 minus how much amount of resistance is this resistor taking? So 2 ampere current is flowing and 0.15 is the resistance. That gives us 1.5 minus 0.3. That is equals to how much? 1.2 volts. The answer is D. Correct? Moving on. Two solid conductors are made up of same materials. Okay? Same length and same resistance. So what is the value? What is the formula for resistance? R is equals to rho L upon A. Now, R1 upon R2 is same. Right? They have circular cross-sectional area A1 and A2 and others. One has circular cross-sectional area A1 and other has a square cross-sectional area A2. What is the ratio of A1 is to A2? It is saying that they have same length and same resistance. So if L1 upon L2 is also 1 and see for the same material the coefficient of resistivity this is same. So in this case to maintain the same resistance the area across both the wires or both the materials should be same. So answer should be P. Moving on. The escape velocity of a body of mass 1 kg from Earth's surface is 11.2 kg, 11.2 km per hour. Now, what is the formula for escape velocity? V is equals to under root gm upon r. This m is mass of Earth, right? It is not at all dependent on which object is trying to escape. It is asking that the escape velocity of a body of mass 100 kg is, it is also 11.2 km per second. Okay. Because the escape velocity does not depend upon the material that is trying to escape. It depends upon the force of the mass of the object that is applying the gravitational force. Correct? Now, moving on. In Young's double slit experiment, green light used is 60 fringes and is when we see in the field. If we use the green light, we can see 60 fringes. And if we use the sodium light, then how many number of fringes can we see? So we have this one formula, right? N1 lambda 1 equals N2 lambda 2. Correct? So now if we just take it, lambda N1 will be how much? 60. And lambda 1 is given as 56, 5461, right? Armstrong. Should be equals to N2 that we have to find out and 5890. If we just calculate it, you'll get N2 is equals to 60 into 5461 divided by 5890. So it will come something around 55. Okay. So the answer is B. In a Rutherford scattering experiment, when a projectile of mass of projectile Z1 N1, see, what happens in the scattering experiment? We try to bombard some electron or positively charged particles towards the center or towards the atoms, right? Now, what happens in this case scenario? Whenever the positively charged ions they try to approach the target here at the center, they get deviated, right? They approach the target of the nucleus Z2 of mass M2, then the distance closest to approach is R0. So, the energy of the projectile, how is it dependent to? This energy is proportional to 1 by 4 pi epsilon naught Z1, Z2 upon R, obviously, right? Because this is also a charge, this is also a charge. So it is proportional to Z1 and Z2. That is your charge. Okay. Moving on. Now, if torque is 0, in this situation, if the value of tau is 0, the angular momentum will remain conserved because there is no angular force getting applied. Correct? So the answer D is true. Lastly, give me a second. Okay. Now, in a full wave, select the correct statement. In a full wave rectifiers, two diodes work alternately, right? So, in a full wave rectifier, what happens? So, we have the current flow that is in the positive, we have alternating flow of current. In a full wave rectifier, what happens? In the first half, the one section of the current, one section of the diode is working in the forward bias and the other section is in reverse bias. When this section comes into action, the lower part of the diode starts working in the forward bias and the top section works in the reverse bias, right? So in a full wave rectifier, two diodes works in alternatively, right? Moving on. Lastly, the work function for aluminium, potassium and platinum is given here as 4.28 eV, 2.30 eV and 5.65 eV. So now they are asking what is the respective threshold frequency. So here we are aware of the formula phi is equals to HV, correct? Now H is constant, Planck's constant, correct? So in this situation, and we have the order of this 4.28, 2.30 and 5.65. We don't need to evaluate it, right? This is for platinum. This is for potassium and this is for aluminium. Lastly, sorry, wrong order. This is aluminium and this is potassium. Now, since this value of H will remain constant, uh, what are we left with? We are left with the value of work function, right? So work function value is given, and and since the value of H remains constant, so the work function is directly proportional to V, right? So the order remains the same. The potassium will have the highest value of highest threshold frequency. Then comes aluminium, and then comes calcium. So option A. Okay. So that concludes our all the questions. As far as I was able to see most of the questions were formula based. There were a few theoretical questions that you would have been aware if you have gone through the theory, but most of the questions were to the point on the formulas. And if you had made a notes of all the formulas, if you had gone through your NCRT books, the questions were not very tough and actually not very time taking for that matter. So for future references and for anyone who has given exam this year or who is going to prepare for the next year, please keep these things into mind. All right. Thank you, students.